Welcome to the deep dive. Think about your day.
Yeah.
Maybe you asked your phone about the weather, or got a movie recommendation. Chances are you've bumped into artificial intelligence already. And that's what we're diving into today. AI. What it really is, how it actually works.
Exactly. We're trying to get past the buzzwords, look under the hood a bit. We've got some great material here that explains it all, from the basics, the history, right up to what it's doing now.
Right. The goal is just to get a clearer picture.
Precisely.
Okay, so let's start with the big one. What is artificial intelligence? Sounds kind of futuristic.
Well, yeah, it can sound that way. But at its core, AI is really about building machines, computer systems that can do tasks that normally need human intelligence.
Like what kind of tasks?
Things like learning from experience, reasoning through problems, making decisions, understanding language, even things like perception or showing creativity. Basically trying to make machines think or act intelligently.
So it's not just about like walking, talking robots.
No, not necessarily. A robot might use AI. It could be the physical body for it, but the AI itself. That's the software, the algorithms making the decisions. Think about Google Translate.
Okay.
It doesn't just swap words one for one. It has to sort of grapple with meaning, context, understand the nuances between languages to give you a decent translation. That's AI working.
Right. Or like those music recommendations I get sometimes, they're creepily accurate.
That's AI too. Spotify, platforms like that, they analyze your listening habits, find patterns, compare you to millions of others, and then predict what else you might like. It's learning your taste.
Okay, makes sense. And what about those robot vacuums? The ones that map your room, is that AI?
Definitely, yeah. They use sensors to see the room, algorithms figure out a map, plan the best cleaning path, and they learn, They get better each time they run. That's problem solving, learning.
Oh.
And chatbots, too, on websites. They use AI to try and understand what you're asking and give a useful answer.
So the fundamental idea is getting machines to do stuff that we'd call smart, if a person did it.
That's a great way to put it, yeah.
Now, it feels really new, but you mentioned history. The idea isn't brand new, is it?
Not at all. The dream of intelligent machines or artificial beings, that goes way back. Ancient myths, early automatons. People have been fascinated for centuries.
Right, those old stories.
But AI as a proper science, that really kicked off in the 1950s.
Okay, the 50s. What happened then? What were the key moments?
Well, a really big one was 1950. Alan Turing proposed what's called the Turing test.
Oh, yeah, I've heard of that.
It's basically asking, can a machine fool a human into thinking they're talking to another human? It's still a benchmark, Then, 1956, the actual term artificial intelligence was coined at a workshop. That's often seen as the official starting point.
So that lit the fuse. What came next? Any major milestones?
Well, jumping forward quite a bit, 1997 was huge. IBM's Deep Blue computer beat Garry Kasparov, the world chess champion.
I remember that. That was massive news.
It really was. It showed that a machine could reach, elite human performance in a super complex strategic game. Then, much more recently, around 2012, we saw the start of what's called the deep learning revolution.
Deep learning, okay.
Yeah, breakthroughs in image recognition, especially with a huge data set called ImageNet. Suddenly, computers got way better at understanding images using these things called neural networks.
Right, like teaching computers to see properly.
Exactly. And things have just exploded since then. Now we have AI generating text that sounds human, creating images from descriptions, making music.
Right.
Even driving cars. It's a massive leap from the 50s.
It really feels like it. But you also mentioned, and the sources point this out, AI isn't just one thing. There are different types, right? Different levels.
Yeah, that's super important. We say AI, but it's not all the same. It exists on different levels of, let's say, capability or intelligence. The material breaks it down into three main types.
Okay, what are they?
So the AI we interact with most often, day to day, that's called narrow AI, sometimes called weak AI.
Narrow AI.
Yeah. It's designed to be really good at one specific task, or maybe a very limited set of tasks. It can be brilliant at that one thing, but it can't do anything else.
So like Siri or Google Assistant on my phone.
Perfect example, exactly. They can understand your voice commands, answer specific questions, set timers, but they can't suddenly, write a novel or diagnose an illness. That's outside their narrow scope.
Okay.
Same with recommendation engines, spam filters, GPS navigation, all narrow AI. Very specialized.
Got it. So what's the next step up?
The next level is theoretical. It's called general AI or strong AI. This is the kind of AI that would have intelligence comparable to a human's across basically all intellectual tasks.
Wow. So it could learn, reason, solve problems, just like us in any situation.
That's the idea, yeah. It would be truly versatile, adaptable intelligence. We're not there yet, not even close, really. It's a huge long-term goal for researchers.
Right. Still in the realm of research and maybe science fiction for now.
Pretty much. And then there's the third type, the one you definitely see in sci-fi.
Superintelligence.
Yep. Super intelligent AI. This is purely hypothetical at this point. It's an AI that would dramatically surpass human intelligence in, well, pretty much every aspect. Creativity, problem solving, social skills, everything.
That sounds intense. Significantly beyond us.
It is. And it raises a lot of big questions, ethical questions, existential ones, which maybe we can touch on. But yeah, for now, it's speculation. The real work today is on improving narrow AI and figuring out the path towards general AI.
Okay, that framework helps a lot. Narrow, general, super intelligent. So let's go back to the narrow AI we actually use. How does it work? It still feels a bit like a black box sometimes.
It can seem that way, but the basic process isn't total magic. It's grounded in math, data, and clever programming algorithms. The sources lay out a kind of step-by-step process. First step, data, lots and lots of data.
Right, AI needs data to learn.
Absolutely. It learns from analyzing huge data sets, text, images, numbers, sensor readings, whatever's relevant. Then you take that data and you use it to train what's called a model.
Training a model.
Yeah. This involves feeding the data into these algorithms, the instructions which look for patterns, correlations, relationships within the data.
So it's like teaching it to spot connections, like we do.
Kind of, yeah. The analogy in the material is pretty good. Teaching a kid to tell cats from dogs. You show them lots of pictures, say that's a cat, that's a dog. The algorithm does something similar, identifying features, pointy ears, whiskers, fur patterns that correlate with cat or dog.
Okay, that makes sense.
So once the model is trained on all that data, it can then look at new data it hasn't seen before and make a prediction or a decision.
Apply what it learned.
Exactly. So you show it a new picture, and based on the patterns it learned, it predicts cat or dog. And then there's usually a feedback loop.
Feedback.
Yeah. You evaluate how well it's doing. If it makes mistakes, you adjust the algorithms, maybe feed it more data and retrain it to get better. It's a cycle of learn, predict, evaluate, adjust, learn again.
That cat and dog analogy really clicks. Show examples, give feedback. It makes the whole training thing much clearer.
Yeah, it helps take away some of the mystery. It's not conscious thought like ours. It's sophisticated pattern matching and prediction based on data, constantly refined.
And ways this is being used now.
Yeah.
It's just incredible. The sources listed so many areas.
Absolutely. It's spreading everywhere. Take healthcare, for instance. AI is analyzing medical scans, x-rays, MRIs, helping doctors spot signs of disease, sometimes even earlier or more accurately than the human eye alone.
Wow, that's potentially life-saving.
Yeah.
What about finance, banks and stuff?
Huge impact there, too. AI is crucial for fraud detection, spotting weird transaction patterns that might indicate theft, and algorithmic trading, where AI makes super fast trading decisions based on market analysis.
And I think you mentioned farming earlier. How does AI fit into agriculture?
Yeah, things like AI-powered drones or sensors can monitor fields. They check crop health, soil moisture, look for pests. Farmers can then use that info to apply water or fertilizer more precisely, just where it's needed. Better yields, less waste.
Amazing. Even growing food is getting high-tech. And travel.
Transportation is a big one. Self-driving cars are probably the most obvious example. They rely massively on AI to perceive the world, navigate, make driving decisions, but also optimizing traffic lights in cities to reduce jams, planning logistics routes. AI is working behind the scenes there too.
And education. How is it used in learning?
We're seeing more personalized learning platforms. AI can tailor lessons and practice exercises to an individual student's pace and learning style, give them specific feedback where they're struggling.
Feels like it's touching almost everything. Entertainment too, right?
Yeah.
Beyond just recommendations.
Yeah. AI is being used experimentally to generate art, write music, even create more believable characters in video games, NPCs that react more realistically. And yes, those recommendation engines are constantly learning what movies or songs you'll like.
It really is everywhere. But with all this power, there are concerns, right? Downsides.
Yeah.
The ethics of it all.
Absolutely. That's a critical part of the conversation, and the sources definitely touch on it. There are some really significant ethical questions we need to grapple with.
Like, what are the main worries?
Well, one big one is jobs. Automation. Will AI take over tasks currently done by humans, leading to unemployment? That's a major societal concern.
Yeah, you hear that a lot.
Then there's privacy. AI systems often rely on vast amounts of data,
Right.
including personal data. So, how is that data being used? What about surveillance? Facial recognition? Big questions there.
Definitely.
And bias is another huge issue. If the data used to train an AI reflects existing societal biases, racial, gender, whatever, the AI can end up perpetuating or even amplifying those biases, leading to unfair outcomes in things like hiring or loan applications.
Right. Biased data leads to biased AI.
Exactly. Plus, things like deepfakes, AI-generated fake videos, or audio raise concerns about misinformation and trust, and just the general question of control. Who governs these powerful technologies? How do we ensure they're used responsibly?
So there's a lot to think about on the responsibility front. Are people working on this?
Oh, yes. Many organizations, researchers, governments are actively working on AI ethics frameworks, guidelines, trying to figure out how to develop and deploy AI in a way that's fair, safe, and beneficial. It's an ongoing, crucial effort.
Okay. So looking beyond the concerns, what about the future? Where might AI be heading? Any exciting possibilities?
The trajectory suggests things will get even more integrated, more sophisticated. Think about personal assistants. They might become much smarter, more proactive, really understanding your context and anticipating needs.
Like a truly helpful digital partner.
Sort of, yeah. The sources also highlighted the potential in developing countries, which is fascinating. Using AI for things like optimizing agriculture in Africa, improving access to healthcare or education through AI tools, that could be really impactful.
That's a really positive angle.
And there's this idea of augmented creativity. AI not replacing human creativity, but collaborating with us, helping writers brainstorm, artists generating new styles, musicians compose, working alongside us.
So less about replacement, maybe more about collaboration.
Yeah.
Humans and AI working together.
That seems a very likely path in many areas, yes. Leveraging the strengths of both. AI is great at processing huge amounts of data, finding patterns. Humans bring context, judgment, creativity. Combining them could lead to breakthroughs we can't achieve alone.
This has been really insightful. It definitely takes AI out of the realm of science fiction and grounds it.
Absolutely. It's complex for sure, but as we've talked about, it's built on principles of math, data, algorithms, smart design. It's a tool, an incredibly powerful one, that we're learning how to wield.
So as we finish up, what's maybe one final thought for listeners to take away from this deep dive?
I think it's useful to remember that AI ultimately is a human creation. We build it, we train it, we set its goals. Understanding even the basics, like we've discussed today, helps us all participate in the conversation about how we want this technology to shape our future. It gives us more agency in navigating what's coming.